Poppin' Boyos, we are back with another Psychics video with Papa Berg.
Papa Berg.
Little G to my homies.
Good stuff.
Good stuff. All right, any questions on the lab from yesterday?
8.
Oh, what do you mean? That's easy, man.
How do you graph? So it's like on an incline, right?
We've on an incline to like.
Oh shoot, I messed up.
Okay,
Yeah.
okay. Let's just chit chat, right?
Let's do it.
Looks like a cut. There's 2 lines.
So here's your incline, right? It's gonna be pretty shallow, right?
Sure.
No.
Shallow owl.
Oh yeah, small block of wood.
Right? Now, which one, and I tell you specifically on here, this is going to be important, small block of wood, okay, towards which the more massive card is going to roll, right? So, I got the little block of wood here. This is the one that's going to have more mass, right? Okay? All right. So, we're going to pop the spring. This is shallow. It isn't like we're trying to do this vertical, okay? It's a little bit of a shallow incline. So as soon as I pop the spring, okay, what's this cart going to do? It's going to go this way, but what's it going to start to do? That's going to start to slow down immediately after it leaves the plunger face, right? What's this cart going to do as soon as it leaves the plunger face? It's going to start to speed up.
Shoot, I messed up. God.
Okay?
Why did it make? I'm so mad.
Okay. I hate it when that happens. Now,
I know, but this one also needs to like.
so assume that the more and I tell you, assume that the more massive card has a positive velocity. So we're defining this direction as being positive. Where are they both going to start?
0.
They're both going to start at 0. Okay? Are they going to go in opposite directions?
Yes.
Yes. Does that give you some guidance?
Speed.
How far do you want this to drive?
Just until I can kind of see that you understand what.
Levels out.
Is this good?
No, it doesn't. Not
Oh, wait.
That's when it stops and it starts to go going
Less
back.
like that. It goes up.
Okay, now,
No?
yeah, no. I have one important question. Let me see it.
Wait,
Let me
this
see
is
it.
the massive.
I'm sorry, please, I'm sorry.
Do you want these two, do you want those two lines to be parallel or not?
And this one's only gonna speed up.
It
This one
has
just goes
the
straight up.
same-
No, it's gonna go straight down. It's negative velocity.
Hmm.
It's gonna go down and then continue to go down.
Okay, then don't draw
But
the
Yes.
that slope is also gonna be twice this slope.
This
Did I
way.
draw the parallel?
Oh, no, this is the thing, they're not parallel.
Because
But
the
I'm
fourth parallel
saying,
is gonna say it's
I just wanted to make sure, because if you want it to be parallel, they're not. If you don't want it to be parallel, then you're cool.
If they
So
are
it's, since
parallel.
it's half as big, it's gonna go twice as
Okay,
fast.
but I think the question is, with the smaller, or the one on that side that's going down the ramp and it's having more square, and it's already
So
going
this,
slower,
the
it
cart
wouldn't get
that's going
slower,
down the ramp has
I guess, no.
So it-
slope.
So
you
it
don't have
still
this,
have the.
like once it stops pushing on it, it's
Well,
going twice.
It just has to be
Oh,
one
like,
straight
I have to go
line.
like that.
It's going twice as fast right there, and then the slope is also.
Yeah, it has to be a little
Can I
quick in
draw
the
like
line.
that?
Like, so from
Continue over here.
this point on,
It's
it's
because
twice
there's
this.
Yes.
So you want this just to be one,
So it's
Right, but
Cause
the
it goes,
acceleration.
All the
and
slope
then
is
it's gonna
right.
keep
Or
on going,
jealous.
nothing slowed it down, though, right?
You're
Because
right.
this slope is also.
So it just-
Yeah, why do you
I guess if the
like
heavier
that?
part hits the edge before.
Does that make sense?
yeah.
It's supposed to be.
read, put yourself in my mindset.
I'm trying.
Read question number 10.
10?
But like, Jake,
Are there any similarities?
explain this.
Are they supposed to be parallel?
Okay. Brooke,
They are not.
riddle me this.
Yeah.
not.
After the spring is released,
Yeah.
what's the force acting on the big cart? What's the only force? Force parallel.
Acceleration isn't the same
Right.
because they're two different masses.
Once the cart, and there's no friction, right?
No friction.
Right? So on a no friction system,
Yeah.
I'm just finding that all slopes are twice
Sine
as big for the
right?
Yeah.
less motion from now.
Yeah, but they start
So
at different.
here's my question. Is the angle the same for both of them?
Yeah.
Well, yeah, they
Then
start
is your acceleration the same for both?
Acceleration
Yeah.
Yes.
becomes the same.
What does the slope of a velocity time graph give you?
Acceleration.
Wait a second.
So they should be parallel
Should be,
because, but after.
the slopes should be the same, just
Okay,
negative
That
and
would
one
be good if they
positive.
were,
okay.
Except for the top one, should just have
Yeah,
it go
this,
back down.
this acceleration is making it slow down.
Yeah.
Oh.
Yeah,
The other
it's just like
acceleration
if
is
you
making
put
it
something
that's
over
if-
open.
Okay, so
Yeah,
it's
so
the
they
same.
are parallel.
So we're going, if you turn it and they
Okay.
never hit the edge.
Because they both have the same amount of
force. Infinite.
So they're both different masses.
Would they eventually just become parallel?
Say that.
Because the only
That was
thing
the time.
affecting them would be gravity?
Because force parallel is just
No,
G
they're
sine.
gonna become parallel as soon as that spring, as soon as it leaves contact.
Yeah, I meant that.
Wait, what is? What's gonna be on parallel?
What? Yeah, that's what I thought.
But no, wait, what? Because force parallel, wait, because there's force parallel is the only force acting on it, right?
Yes.
But one of them is more massive than the other, so it's gonna accelerate at
The
a
acceleration
smaller
is-
rate, right?
Yes.
Not after they leave. Because on a frictionless surface, A equals G sine theta.
Oh, shoot.
There's no mass, you don't take a mass
There's
into
no mass doesn't even
So they
take
are,
into
so they are
account.
parallel.
Because the mass is gonna cancel out.
God dang it, I have to erase everything.
I don't know how to do it.
Thanks, Barb.
Thanks.
Thank you.
Neither.
I don't know.
Don't think I like any of you, let's be honest.
No.
Yeah, you
I'm
won't even
kidding.
tell us where you live. You can't even hang out.
Well, we're already gonna find out.
Don't
You
worry, I
can't
know.
even hang out, work.
Okay.
The key.
The key?
The key.
The key to what?
My heart.
My heart. Yeah.
Oh, shoot.
All three of you. Jamie went like this.
This is my heart.
If you say the key to something, it's gotta be the
I don't
key
like
to my
this
heart.
dang-
Oh, I didn't know. It was
Give me a sec, I'll fix it.
The key to
It's hurting.
Yeah, it's that little.
It's conversation.
This little thing right here.
Why are you all stalkers?
Why are
We
we?
just want to
We're
hang out.
researchers.
We're researching the location.
We are scientists!
Physicists.
Physicists.
Psychic six.
Physicists.
Psychics. We're psychics.
Psychics.
Physicists.
Psychicists.
Psychicists.
Yeah,
I like
that's it.
psychic.
Psychocists?
Psychic. I like the blue dots. It's really nice.
Yeah,
So nice.
kinda goes with the,
Kinda
goes
goes
with the shirt.
Yeah.
Yeah.
Love
You've had that
it.
belt for a long time.
And the tie kind of, the green kind of goes with the,
Yeah.
yeah.
In the style.
Nice
Why
dots
are
and
graphs
little put
different? They're
together.
different because there's both of
Okay, now,
them, right?
more so than any other time I've ever taught AP Physics, I am concerned about many of your grades, okay, which suck right now for some of you. Mainly because we haven't had that many assignments and some of you are missing, like one lab right now was 20% of your grade, and some of you don't have any score for that, so right away you're kind of screwed. So I'm handing this so that I want everyone to be perfectly clear of what your grades are right now. Okay, now we still have a long way to go. The one test we've had over 60% of your grade. Some of you still haven't handed in the test corrections. For the love of God, to get the test corrections in. I'm giving you 40% back on your test corrections. Okay, that's a gift. Do the test corrections. So I want everybody to know exactly where you're at with your grade right here, right now, so that no one's going, I didn't know that. Yeah, you do. So.
I know.
Brooklyn.
Thank you.
Okay.
Ew. What am I missing? Oh, that one.
Okay.
Which one is, I'm missing this one. Is that the yellow sheet? Is that the yellow sheet?
Preston.
No, it's not the yellow sheet. It's, yeah, it was it. No, this was the yellow sheet.
Yeah. This is the one that we had.
Oh,
Over
yeah,
the time.
because it's 20 minutes.
that we just didn't do. Hey, could I have my ruler? Oh shoot, yeah. My
It
bad.
says,
Signing
it
it.
says signature, I gotta sign it.
Finish the test.
Yeah, no.
You got like eight
Official
tests.
decided
Tests.
to signature, I gotta sign
You've,
it.
you've acknowledged that you got it.
Yes, I,
Okay.
I make money moves.
yes,
See?
I,
Set.
All right, so here's what, today is kind of a catch-up, yet closure kind of day in terms of like linear momentum. So what I'm gonna do is I'm gonna give you this little strip of paper that has Brooklyn noted that I cut out, okay?
She's gonna start cutting them.
Okay, and it has one problem on it, and we're gonna work through it. And, because I promise you on the test, which is looking like to be, probably a week from today, okay?
Don't make it Wednesday.
It's not, that wouldn't be a Wednesday.
I know, just don't be like, I'm pushing back a day, unless you can push back 2 days, but not 1 day.
Okay, duly noted.
Thank you.
Duly noted.
I need some space.
Okay, so we're gonna shoot for the test being a week from today. So here's the deal, I promise you, there's gonna be a problem like this on the test. I promise you, okay? So we're gonna work through it, we're gonna make sure everybody knows how to do it, and then we're gonna finish up with a little bit of a video, and you don't have any homework.
Oh, what?
Whoa.
I'm gonna
Yes.
have homework tomorrow on
Yes, sir.
Halloween.
That's what I like to hear.
Not as bad as my honors physics class, because they have the big planetary and centrifugal motion test on Thursday,
Oh.
the day after.
Wait, can I get my
Thanksgiving.
assignment now though?
The
So
day
I
after
can actually do
Thanksgiving.
it like Can I get my tomorrow's assignment now though? Do you have it printed?
We have Gov.
Yeah.
Because I might actually do it tonight.
But without the lecture, it's not gonna make much sense.
I'll figure it out.
Oh,
Let's see how much I can figure out.
It's probably
Honestly,
angular
yeah.
momentum.
Oh, shoot. Is it angular momentum?
Yeah.
Oh, yes.
And angular motion, it's a whole new set of variables.
Mm-hmm.
Motion, yeah. It's kind of.
Oh, yes.
Yeah, it's in the motion.
Don't worry, we got those videos. Yeah, what are you saying?
And then you hit a pothole.
Okay, I lied. Don't give me the assignment.
Uh-huh.
I lied. Don't give it to me.
Wait. Oh, you did.
Come on, Joel, you have to try.
No thanks. I'm not trying to fail.
No, he doesn't.
No.
No, he doesn't. Okay, so here's the setup. All right, so you've got a ball that looks like Gary the golf ball. And you're gonna drop it from a height of 1.85 meters, because the floor is gonna bounce back up to a height of 1. So we're here, right, 1.85 meters. I'm gonna drop it, and then it's gonna come back up to here. So we're going from here, doink, doink, okay? So, that's all the information that you've got. So what I wanna know is, it's gonna hit the floor, it's gonna bounce back. So, out of all of that, I want the force required, the velocity time graph defined down as negative, and the ground is 0.0 meters. So, here's the setup. Ball's gonna come down, it's gonna hit the ground, it's gonna bounce back up. We're defining this ground as being 0 meters. Anything going down is negative, anything going up is being defined as positive, okay? So, here's what I want to look at, okay? So let's think this through. First off, is the momentum of the ball ever going to be constant?
No,
Why not?
gravity. It's always putting acceleration on it.
Okay, so there's always a net force acting on the ball, right? Okay, so is our velocity time graph ever going to be a horizontal line? No. Okay, velocity time graph is never going to be a horizontal line because our momentum is always changing, right? Okay, so we're cool with that. Now, let's kind of think this through. Is the ball going to change direction?
Yes.
Yes. How many times?
Once.
Once. Now, is that, hold on, give me one second. Ben, come here. I need these new batteries to put in these stopwatches. So just basically take the plus, you've got to watch. Here, if there's like an O-ring, this is inside here, you've got to be careful, and you've got to make sure that this string, let's put that. Sometimes we can hold it like that. So, there's my pocket knife, which you can get in this light, so. Five. So, you strap it all on, go back in here. Okay. So, Gary, the golf ball is going to fall, it's going to hit down, it's going to bounce back up. So let's talk about the velocity time graph first. Okay, let's just get an idea of what the velocity time graph is going to look like. So, where's the velocity time graph even going to start? Zero, why? We're going to drop it, right? Okay. So, velocity time graph is going to start at 0. Then what's it going to do?
Speed up.
It's going to speed up. So it's going to go up, or is it going to go down?
Down.
Why down?
Down is negative.
Going down.
It's slowing down. We're starting at 0, and we're slowing down.
No, it's going down.
Going down. Okay.
For real.
For real. Okay, something like this. What's the slope of that line as it's going down?
9.8.
Negative.
Negative.
9.8 or
Negative.
Negative.
negative 9.8 or gravity. What's the slope of the line? Gravity. Really?
Obviously.
Really. Okay. So at this point, here's what's going to happen. The ball, which I just lost, the ball is going to hit the ground, right? So the ball is going to hit the ground, and then what's it going to do? It's going to bounce. So what's going to happen here?
Cross the x-axis.
Why, Jason?
Because it changed direction.
Okay. So is that going to take very long?
No,
Why not, Cale?
because it's only in contact with the ground for like
Yeah, it's just
0 to 2 seconds.
okay. It's going to happen like very, very quickly. So at this point, it's going to hit the ground, right? Going to hit the ground. So then this graph is going to do what?
Shoot up.
It's going to go up, something like this. Now, here's the question. I don't know what this velocity is. We'll deal with that later, okay? I don't care. But it's going to hit the ground. So if you think back to that spring cart lab that we did where you pushed the cart against the wall. So what's happening during this segment of that graph? Physically, what's happening to that ball?
Compressing.
It's compressing, right? It's storing energy, okay? So this has a little bit of compression action going on, right? So then, what's going to make it bounce? Whoa, what's going to make it bounce back up?
Releasing.
It's going to expand, right? So, here's the deal. Is this velocity here going to be bigger, smaller, or the same as the velocity when it hits?
Smaller.
How do you know?
Because it doesn't go up as far.
Yeah, because if it was the same, what would the ball do?
Go back to the same height.
Yeah, which would be the ultimate physics demo. Is that I drop this ball, I walk away, I keep lecturing, okay, and an hour later it's still bouncing back up to the exact same height, okay, which would be cool, right? Don't get me wrong. But there's this concept of energy that we kind of have to deal with. We'll talk about that later. So, whatever velocity I have here, right, this velocity up here has to be less than this. So like if this is -8, this would have to be like maybe +6. So I know this number up here has to be a positive number, but smaller than the velocity that it had when it hit. Okay? So we're compressing the ball here. That stored energy is expanding, okay? That's what's making that ball go up. Because if I drop an egg, what does this graph do? Yeah, it's cool up to here, and then what? Right there, okay? So you get a compression, but that's it, Okay, because the eggshell doesn't have the capacity to store energy, whereas the ball does. So, this is like a stored energy, okay? Remember, Mother Nature doesn't like stored energy, doesn't like potential energy. Mother Nature likes things that move. So, I'm compressing this ball here. That ball is going to expand. Now, at this point, we're going to leave the floor, okay? So we've come in, we've hit the floor, and we've left it. So at this point, we're going to leave the floor. So what's that graph going to do?
Oh no, yeah, it's gonna
Will
start
it
going
keep
down.
going up,
What?
No, it's gonna go
No,
down.
it's gonna go down because.
or will it come down like this?
It's gonna come down.
Go down.
So y'all are saying it's going to come down like this.
Yep.
Will this line be parallel with that line?
Yep.
Yes.
Why?
Acceleration's the
Because
same.
the force acting.
Yeah, because what's the force acting? What's the only force acting on it at that point?
Grab it.
Gravity.
So these two lines are going to be parallel. Makes sense. So we're going to hit, compress. This is when the ball was stopped at the bottom. That cover is going to expand a little bit. It's going to push that ball back up. At this point, we're going to leave the ground, and then we're going to come back up. So where is the ball at this point?
The beat, yeah.
Is it back at the ground at this point?
No.
Where's the ball?
As at its highest
At its maximum height, which is going to be 1 meter. So we're here, we drop it, it comes back up to a height of 1 meter. Everybody good with that? Okay, now the only thing at this point we have to do is figure out the numbers. So I need to figure out how fast it's going when it hits here. Now, before you do anything, let's think this through. What's going to be the sign of that velocity?
Negative.
Negative. Why?
It's down.
It's going down. So I'm going to hit with some velocity that's going to be a negative number. When it leaves, what do you know about this velocity relative to that velocity?
Positive.
It has to be positive and less. So I know this number has to be a positive number that's less than the velocity that I have when it hit. Now, if it was bigger, what would that mean?
It'd go up higher.
Yeah,
So
it's
it'd
like, that
super
would be
cool if
really
it
cool.
did.
You drop it here, okay? And then after a while, it starts going bouncing higher and higher and higher. Energy crisis solved right there. All we have to do is just bounce the ball and let it hit something and turn it into electricity. Okay. Good with this. So what's the only thing we really have left to do?
Figure out the number.
Yeah, figure out the numbers, okay? So, let's talk about the numbers. So I've got coming down to a height of 1.85 meters, right? So, what's the initial velocity going to be? Zero. Okay? So, my final velocity is what? I don't know. So what am I going to use to find that velocity at impact?
280.
That equation.
Well, let's go with that equation. We'll simplify to that, but let's hold that thought. So, you got v squared equals v naught squared plus 2ad. True? Now, on this problem, which is going to be on the test, I'm telling you right now, you're going to have a problem like this on the test. You mark my words. And I want you to show every step of every calculation, including the signs on everything. I'm going to tell you straight up. That's one of the things I'm going to look for. So, are you searching for V naught, or are you searching for the final velocity?
Final velocity.
Final velocity. The initial velocity is going to be
0.
because we're going to drop it. Now, we get to V equaling the square root of 2AD. So, here's what you're going to do wrong. Or what do you think? What do you think you're going to do wrong on this part? No, beyond that.
We're gonna forget to make a negative, right? After the square root.
9.
Jason, what did you say?
Use negative 9.8
Oh, that's not a problem.
with a positive 1.8.
Yeah, so you're going to come here and you go, oh, negative 9.8 meters per second squared times 1.85 meters. So why is that not going to end well?
Because now it's imaginary.
Well, yeah, we have an imaginary velocity. Okay? Now, so there's two ways that this thing you can roll this. You could just ignore the negative sign. Okay? There we go. Problem solved. But why can't you do that in terms of this graph?
It's a negative slope.
Yeah, it's a negative slope. Okay? But here's the gig. What's your initial position? No. What's your initial position?
1.85.
1.85 meters. The ground is defined as 0. So your final position is
0.
0. How do you calculate displacement?
Final.
Final minus initial. So if I take 0 minus 1.85, I get negative 1.85 meters. Ah. Now I've got two negatives underneath the radical. Now I'm good.
Imaginary.
Okay? So I'm telling you, on the test, look, I'm going to look for this step, that you have these two negatives underneath the radical. But this is where your calculator will lie to you. So somebody do the numbers. Take 2 times 9.8 times 1.85, and then take the square root of that.
Or pulled up.
What'd you get? 6 point what?
Negative 6.02.
But your calculator, I promise you, doesn't tell you that it's negative 6.02.
No, that's.
What does your calculator tell you the answer is?
Positive.
6.02. It just says it's 6.02. But being clever math students that you are, since it's a square root, you have
Plus or minus.
2 possible roots. So this is going to be plus or minus. So what do?
Negative.
Choose the minus.
Yeah, you just choose the negative root. Okay? There you go. Easy peasy. So what this means is, here's what I know. At this point, I know that impact velocity is negative 6.02 meters per second. So right away, what do I know about this velocity up here? It has to be less than
6.2.
6.02. Because if it took off at 6.02, guess what? How high would it go?
The fold.
Yeah, you go back up to 1.85 meters. Okay? Since it only goes up to 1 meter, I know it isn't. I know that velocity has to be less than 6.02. Okay? So think the problem through. Okay? Think the problem through. Now, what happened at this point has no bearing at all on the next part. Okay? It has no bearing at all. So basically what I'm asking is that how fast does this thing have to go from a certain velocity up to a certain height of 1 meter with an acceleration of negative 9.8 meters per second squared. Right? So here's the difference. I know this took off at negative 6.02. That has no bearing on this next calculation. Okay? It has no bearing at all on this next calculation. Because on this one, I'm going to end up at 0. Okay? But I've got to figure out how fast I've got to be going to end up at that height. So could I use that equation again?
Yeah.
Yes. Okay? So on this one, I can use that equation a second time. So I could go v squared equals v naught squared plus 2ax. True? Now, but here's the difference. Am I searching for v naught or am I searching for v?
You know,
Why?
because you know the final velocity is 0.
Yeah, I know my final velocity is 0. I'm searching for how fast this thing has to go to end up at that height. Okay? That's what I'm searching for. So I need to get this by itself. So I'm going to have v squared minus 2ax. The square root of that is going to equal v naught. So here's the difference. Okay? Here's the fundamental difference. Is that on the way down, I was searching for my final velocity because I was starting at 0. On this one, I'm searching for the initial velocity, and I know the final velocity. even though it's the exact same equation, how you handle the math is completely different, okay? It's completely different. Now, here's where the magic happens in terms of sign. What's my final velocity going to be?
Positive.
No. What's my final velocity? 0. What's my initial velocity? That's what I don't know. Now, what's my acceleration?
Negative 9.8.
Still, negative 9.8 meters per second squared. Okay, that's cool. But now, what's my height?
1. Positive.
That's 1.0. My bad. That's just going to be 1 meter. Now, this is why you have to pay attention to the signs. Okay? Because now I have 0 minus a negative number. Now what happens?
Cancel.
Now I get a positive number underneath the radical. Guess what? Now I'm golden. Okay? So that's why I said you have to work this problem holistically. Don't try and pick and choose, oh, sometimes I'll make G negative, sometimes I'll make G positive. If you work this problem consistently, you're going to be fine. It's when you try and switch signs with G, this is where that turns into a train wreck. Okay? So, somebody run the numbers.
4.43.
4 point.
4-3.
Now, do I want to make that positive
Yeah.
or negative?
Positive.
Why?
Because now it's going up.
Because now it's going up. Okay? So at this point, here's what I know. So the ball came, it hit, right? It bounced, and at this point, I know this thing is leaving at 4.43 meters per second. So does that answer make sense with what we said? Because we said it was going to be less than 6.02 and a negative number. Now at this point, do I have enough information to calculate the change in momentum of the ball when it's in contact with the floor?
Yes.
Yeah, because what's the easiest way to calculate the change in momentum in this case?
Mass times
Force times time or mass delta V?
mass delta V.
Mass delta V. Now, this is where this gets tricky, okay? This is the most potential hang-up. Here's your potential downfall. Okay? So, change in momentum is going to be mass times V minus V0. So, let's go back to that velocity time graph. So we had this, some action like this. This was negative 6.02. What was the last one we just found? 4 point. What was that last velocity?
4.43.
4.43. Okay. So I've given you the mass of the ball, 254 grams. Okay. So that's 0.254 kilograms.